Hi friends, in today's session we will discuss about the TCP header and its fields. So let's get started. This is how the TCP header looks like, and we shall discuss about each of the fields in the upcoming slide. Source port, it's a 2 bytes field, identifies the port of the sending application, and normally the client machine chooses a random port number to initiate the connection. If application A wants to communicate with application B, it starts the communication by selecting a random port number as the source and starts to listen on that port for the response sent back by application B. Destination port is also of 2 bytes. It identifies the port of the receiving application. But here, the port numbers on the destination side most of the times are well-known port numbers. Just to give you an analogy, consider an apartment and assume apartment address as an IP address and flat numbers are the port numbers. If you want to send a parcel to a particular flat, you will have to mention the apartment address as well as the flat number to rightly deliver the parcel. Else there is no way for the delivery person to deliver the parcel to the right address. Likewise, there are thousands of applications running on a computer. So how do you differentiate each application? And that is where the port numbers come into picture. The next field is the sequence number. As you know, TCP is a reliable protocol. It basically works by sending an acknowledgement back to the source once the data is successfully received. If there is no acknowledgement back from the receiver, that means the data is not delivered due to some reason, and the sender retransmits the data. This reliability of the protocol comes from the upcoming fields. Sequence number is a 4-byte field. When you establish a new TCP session, initial sequence number, a random 32-bit value is chosen. So as you know that when a TCP session is established, there are 3 packets which are exchanged, which is SYN, SYNAC and ACK, and that is called as a 3-way handshake in TCP. The receiver will use the sequence number and send back an acknowledgement. When you look at the packets in a Wireshark, you would not see a random number, but Wireshark, for our ease of troubleshooting, it uses a relative sequence number and it always starts with 0. When a data is received, the receiver has to respond back to the sender saying that it has successfully received the data. To do so, it uses the next field, acknowledgement number. It's a 4-byte field. It contains the sequence number of the data byte the receiver expects to receive next. The acknowledgement number is the last byte plus 1. For example, if 10 fragments were received, the acknowledgement number would be 11, saying I have received till 10, now send me 11 onwards. Data offset is also known as header length. It indicates the length of the TCP header. Header length varies between 20 to 60 bytes. Minimum length 20 bytes and maximum can go up to 60 bytes. So you must be thinking, how does it bulge up to 60? Option field, yeah. If you look at the TCP header, there is an option field which can expand up to 40 bytes depending on type of the data. Summing up option field with the other field gives us 60 bytes. Also remember that header length uses a scaling factor of 4. If you look at Wireshark, you will normally see values in binary. For example, 1000, which represents a decimal of 8. Decimal 8 into scaling factor 4 gives us 32 bytes. I'll show you this in the Wireshark captures in the coming slides. RSV is the reserved field. It is always set to 0 and is kept for future purpose. TCP does not use a separate frame for control messages. Certain bits in the header are set to communicate control messages. We use them to establish connection, send data, and terminate connections. Urgent flag, it works in conjunction with urgent pointer in the header. We'll discuss this field later. If urgent flag is set to 1, it informs the receiver that certain amount of data within the current segment is urgent. Acknowledgement flag. If this is set to 1, it indicates that this is a ACK segment. You will normally see this in a 3-way handshake as a response to the SYN packet received. Push flag. When push flag is set to 1, it means all the segments in the buffer gets pushed to the receiver immediately. Do not wait for the buffer to get filled up. Reset flag. If set to 1, it resets the TCP connection. SYN flag. If set to 1, it indicates this is the first packet sent for connection during the three-way handshake. Finish flag. If set to 1, it indicates the receiver that the source wants to terminate the connection. Window size is normally negotiated between the sender and the receiver during three-way handshake process. It is used by the receiver to inform the sender how much of a data it can currently receive. If window size gets to 0, it means receiver buffer is full and it is asking for the source to pause the data transfer. Checksum. This field is used to verify the integrity of the data in the TCP payload. Sender runs a CRC algorithm and generates a value and saves it in the checksum field. Receiver, upon receiving the header, it runs the same algorithm and generates a value. If both the values match, data validation passes, else receiver rejects the data. Urgent pointer. It works along with the urgent flag we discussed earlier. It tells us how much of a data is urgent. Options. This field is optional and can be anywhere between 0 to 40 bytes, generally used for the purposes like timestamping, padding, etc. Let's take a look at the Wireshark capture and see how the Ethernet header looks like. Here the source port is 6711, destination port is 2000. Sequence number is 0 as it's the first packet sent in the TCP three-way handshake. Usually this is a random number. However, since Wireshark, as I said earlier, uses relative sequence numbering, it is always set to 0 for our ease of understanding and troubleshooting. Header length is represented by binary 1000. Its decimal is 8. 8 into scaling factor 4 gives 32 bytes. How is this 32 bytes, you must be wondering. Look at the last field options. It's 12 bytes here. So 20 plus 12 bytes of options equals 32 bytes. I can say it is a SYN packet by looking at the SYN flag set to 1. Next we have the window size, which will be negotiated between the source and the receiver, and then the checksum value. Next comes the urgent pointer. So at this point of time, there is no urgent data to transmit, so it's set to 0. And then finally, you have the options. I hope this session was informative. Thank you so much for watching and have a good day. Thanks.